Hi, it's Mr. Adams from Medical High School, and this is a video on half-life. Okay, half-life is the time it takes, okay, for half of a radioactive substance to decay. Your reference table N has a list of half-lives for you, and it also has a list of decay modes, so please check that out, all right? This graph in the left corner right here is a general shape. If you plot half-life data. Okay, it always has a general shape, and very importantly, half-life is unaffected by temperature, pressure, concentration, or anything in the environment. Okay, so it is what it is. Okay, it's not affected by any outside influence. One note on the side, folks, is that in terms of transmutations, right, we have natural and artificial, which we discussed in class, and we also discussed the fact that natural transmutations always have only one substance on the reactant side. So out of all these reactions right here, right, this guy right here, number 4, would be an example of natural transmutation. These guys would be an example of artificial transmutation, okay, because we notice that we have particles being smashed into various elements to produce totally new substances. Okay, so it's artificial transmutation, and this one is natural transmutation. Okay, now the nice thing, guys, is a nice relationship between the number of half-lives and the fraction remaining, okay, which we'll take advantage of. If we have one half-life, right, the fraction remaining would be 1/2 to the exponent of 1, which will be 1/2, right, and that percentage will be 50%, all right, okay. If we have 2 half-lives that passed, right, the fraction remaining would be 1/2, okay, to the second power, okay, which is be equal to a quarter. Now, from experience, we know that a quarter represents 25%, and so on. If you have 3 half-lives, you would have 1/2 to the third power. The fraction remaining will be 1/8, okay, and you do the division to get 12.5%, and so on. Okay, now if you know the fraction remaining, okay, you know the number of half-lives. If you know the number of half-lives, you know the fraction remaining. So they're interchangeable and they're very helpful. Okay, we have a couple of problems here, right? So what we're going to do, all right, we'll pause the video and we will see how we do. Okay, all right, the first question is asking us how many days will pass, all right? We're trying to figure out how many days will pass, okay? If a substance, okay, with a half-life of 120 days has 50% remaining. Now that number should be familiar to you because we just talked about it. We just discussed the fact, guys, that if you undergo, right, 1 half-life, right, your fraction remaining will be 1/2, and the percent remaining would be 50%. Okay, so what essentially it's saying is you have 100% of substance, it undergoes not decay, okay, and after 1 half-life, you will have 50% of it gone and 50% of it remaining. 50% of it will be turned into something else. Now, 50% always represents, okay, 1 half-life. So since 1 half-life is 120 days already, that will be our answer. You're done. Now, a lot of times, guys, this is how simple these problems are. They just wanted to see that you understand the basic concepts. All right, for the next question, number 5, right, they gave you the half-life of 4,700 years, all right? They said how many years are required for 3/4 of a given amount to decay. Now, the thing is, if 3/4 of it decays, right, what does that mean in terms of amount remaining? Okay, we know that 3/4 and 1/4 give us a whole, right? So we have a quarter remaining, and that fraction, once again, should be familiar to us, because if we have a quarter remaining, right, a quarter remaining refers to 1/2 to the second power, and that too tells us something. That too tells us that we just used 2 half-lives, all right? So therefore, if we know that 1 half-life is 4,700 100 years, okay, we will simply multiply by 2 to get the total time elapsed, and 4,700 times 2 should be equal to 9,400. Okay? All right, so it's 214, 4, and 8, 9. Okay, that sounds good, 9,400. All right, we're moving on. Next question. We have a half-life of thorium-27, right? Given as 18.72 days, okay? And the question is asking how many days will pass, right, for 4.6 grams to remain if you started with 74.88 grams. Now, there's more than one way to do this problem. You can put a box in the corner right here, and you can start it with 74.88, all right? And you can cut it in half until you get to 4.68, right? Or you can simply say, okay, if I have 4.68 over 74.88, right? I can say that 4.68 into 4.68 gives me 1, and 4.68 into 74.88 gives me 16. Okay, I can do it like that. And what can I do from there? I can simply say that I know if my I have 1 over 16, that represents 1/2 to the 4th power, right? Okay, and if I know I have 1/2 to the 4th power, this number right here, this 4 represents 4 half-lives, all right? So if I went through 4 half-lives, the total time in terms of days would be 18.72 times 4, all right? And 18.72 times 4 should be 74.88 days, okay? And that's my total time that passed. Alrighty, okay, and moving on to the last one, okay? We are given the fact, okay, that we have carbon-14. Remember from our notes that carbon-14 is used to find the age of previously living substances. They said that the half-life for carbon-14 is 4,700 years, right? Now they're asking how much of an original sample, 0.5 gram sample, remains after 14,100 years. So essentially what are you doing? You're starting with, okay, 0.500 grams, okay, and they're trying to find out how many is left after this time passes. Okay, so what we simply can do, guys, is this. We can simply either do a division and figure out how many half-lives, okay, and go from there. All right, so we have 14, right? 1,100, right? All right, and we know that we have our half-life as 4,700, okay? All right, so when I divide 14,100 by 4,700, right, I will get 3. That's telling me that 3 half-lives passed in terms of 14,100. So I can simply do this. If I started with 0.5 grams, right, and I undergo 1 half-life, that cuts it into 0.250 grams. I use another half-life. I cut that into 0.125 grams, right? And since I did 3 half-lives, I'll cut it in half once more, and I will get 0.0625 grams, and I'm done. That's my final answer, all right? So once again, people, there's more than one way to do these half-life problems. Choose the way that's easiest to you. They're not hard. They're quite simple. Understand this relationship. The number of half-lives tell you the fraction remaining. The fraction remaining tells you the number of half-lives. Also know the percentages associated with the fractions. Just simply divide and multiply by 100, and you're good to go. All right, as always, hard work plus sacrifice equals success. Take care.